Dear students, in today's session we will discuss about non-parametric tests and a few examples of non-parametric tests. Basically we will deal with chi-square test. Okay, so this is a theory session, purely theory session, and in the coming videos, that means in the next video, we will discuss about different problems wherein we are using the chi-square test. Okay, so what do you mean by non-parametric tests? Non-parametric tests are the mathematical methods used in statistical hypothesis testing. So, non-parametric tests are experiments that do not require the underlying population for assumptions. It is also known as distribution-free test. Normally, we discussed about like Z test, that is normal distribution. Then we discussed about T distribution. All these things are parametric tests. Okay. That means we require certain distributions, we require populations and etc. But here in case of non-parametric tests, similarly the same way as we have tested the hypothesis, this is also another method of testing the hypothesis. But here we need not require any distribution. Okay, it is completely distribution free and we are not depending upon the underlying population also. There in case of Z test and T test, we were bothered about the distribution, different type of distribution, as well as we were bothered about the population size, sample size, etc. But here we are not bothered about the population nor the underlying distribution. Okay, so few examples of non-parametric tests is chi-square test, Mann-Whitney test, Kruskal's-Wallis test, etc. So basically here in case of MBA syllabus, you will have to study about chi-square test. Okay, this is very important test wherein we are trying to find the goodness of fit using chi-square. Okay, now let's see what do you mean by chi-square test. So chi-square test is a type of non-parametric test, and basically you need to study this particular formula in order to solve problems using chi-square. It's a very simple formula, that is chi-squared is equal to sigma of O minus E squared divided by E, wherein O is the observed frequency and E is the expected frequency. In most of the problems, both these things will be given, right? That is the observed frequency and expected frequency will be given in the question. If ever expected frequency is not given, then definitely you will have to find out the expected frequency. That is, if it is given in a tabular form, then there is a formula for calculating the expected frequency that I will discuss once we start doing the problem. And an example of chi-square test will be done in the next video. Okay, now there are certain things that you need to understand while we are performing chi-square test. That is the conditions for chi-square. The number one is observations recorded and used are collected on random basis. Okay, this is like we are randomly collecting the samples or observations. Fine, here it is not following any particular pattern, it is on random basis. Then all members or items in the sample must be independent. They should be independent of each other. Then no group should contain very few items. So here basically we are performing chi-square test in case of large samples. Okay, so definitely the sample size should be very large. Overall number of items must be reasonably large and the constraints must be linear. Then expected frequencies of less than 5 is pooled with the preceding or succeeding frequency so that no expected frequency, that is capital E, is less than 5. Now in case of in a problem all the expected or observed frequencies are given in tabular form, like different group A, group B, group C, if that is given in that way, and if you find that there is some group wherein the number of items is less than 5, then you will have to club it with the other group, either the preceding group or the succeeding group, because all the expected frequencies should be more than 5. It cannot be less than 5, because in chi-square we are talking about large items or a large sample size. Okay, and here chi-square test describes the magnitude of difference between the observed frequencies and frequencies expected under certain assumptions. So here basically what we are testing is we are testing the difference, that is the magnitude of difference between what is actually calculated and what we are expecting under certain conditions. Okay, and here the values of test will range from 0 to infinity. So in case of chi-square the range is from 0 to infinity. Now this is just the theory of what is chi-square. Okay, once we start doing the problem. Okay, then some few applications of chi-square is it is useful for test of goodness of fit. Then useful for the test of independence of attributes, whether they are independent of each other. Then useful for testing homogeneity, and useful for testing given population variance. So we are trying to test the variance, we are trying to test homogeneity, then independence of attributes and goodness of fit using chi-square. So these conditions, that is 7 conditions for performing chi-square test, should be correctly understood. Okay, so when we are using chi-square is basically used when there is large sample size and we are taking samples on random basis, that is, it is not particularly following any pattern. Then definitely the constraints must be linear in nature, and your expected frequencies should not be less than 5. Okay, it is basically a non-parametric test. That means here we are not depending upon the parameter, it is completely distribution free. Okay, so when we discussed about that Z test or T test, it was not distribution free, they are following normal distribution or T distribution as such. Okay, that is a continuous pattern. But in case of chi-square or any non-parametric test for that matter, it is distribution free, and definitely we are not depending upon the population. Okay, so that is all about the theory part of non-parametric test, and especially the chi-square test. In the next video we will discuss a problem, how to solve a problem using chi-square. Thank you, students.